Hello everyone. In one of the previous videos, I showed you how you can use Docker to containerize your Flask-based web application. So there were a couple of videos on my channel previously. One of them was training a deep learning model for skin cancer detection. Then we created a web app. Then we wrapped the web app inside Docker. So a lot of people asked me, how would you use Docker to train the model instead? So this is what I'm going to show you in this video. And if you're not familiar with the previous videos, I would highly recommend you to go and take a look at how to train skin cancer detection model and how to build the web app and how to Dockerize the web app. You can skip how to Docker. No, you should not skip Dockerize the web app because I'm using some of the things from there in this video. So in this video, we are training the deep learning model. And as you already know, as some of you already know, that I created a simple library called, well, that's fantastic machine learning. And here it's like a wrapper, so simple functions that I normally use. So this is what I'm going to be using, but since I'm changing it actively quite a lot, I have to tell you that you must use a given version. So let's see the code. First of all, we will create the training code. So we have already done that previously in one of the videos. So here I'm just walking you through the training code quite quickly. I have changed a few things, but not a lot of things. So let's take a look. So the first thing that I have modified here is I have removed Nvidia epics. So why I have removed? Because just to keep this video a little bit simple. Then I have added this data path. So this folder on my local machine consists of all the data. Then I have the model. It's the same model from one of the previous videos. You have already seen that. And then most of the stuff remains the same. So what changes is, since I've removed Apex, I remove the line when I'm wrapping the model for automatic mixed precision. So that's not happening anymore, and FP16 is false. So that's the only change. And I must tell you that I'm using WTF-ML 0.002. And now I think we have everything here that should be sufficient to train the model without Apex, obviously. So what I'm going to do is I'm just going to do head 1000 just to make sure the model trains quite fast, and then we are going to train this model and see if it's training or not. So I am here and I can just write Python. Okay, let me make it a little bit more bigger for you. Okay, so I can just write Python and then the name of the file, which was main.py, and I hope this trains the model. So let's wait for it. Okay, so the model is training, and since it's only 1000 samples in training, it should be quite fast, and it is. And now we have the validation step going on, and everything will be done by this wrapper library that I'm using. So we can see it's generating some kind of score and it's saving the model. So everything is working fine without Apex. And now we go back, and here, now I have to reduce the size of this. Now here, what we have is we have created a Docker file for kind of like deploying, so wrapping the Flask app. So we will take everything from here and create a new file called dockerfile_train and paste it here. So one thing that you have to remember now, since we are using the base image of Ubuntu 18.04, right? Ubuntu 18.04 does not come with CUDA and QDNN drivers. So you have to install them yourself, or you can do something else. But before we move there, one of the things that you must do if you want to train a deep learning model using Nvidia's drivers is install the runtime, the Docker runtime that Nvidia provides. So it's very simple. So you go to Nvidia Docker repository and you scroll down a little bit, you will find the README, and there's instruction for Ubuntu and other types of distributions of Linux. So what you do is you can just copy paste all these commands and you run them in your terminal. So it's not very difficult, and it takes quite a few minutes, and after that you're done. It's a one-time step. So once you're done with that, now we go back to our Docker file for training, and here instead of Ubuntu we will use something else. So what you can use here, you can get anything that you want from Docker Hub. So hub.docker.com, and there you go and search for whatever kind of images you want. So Nvidia CUDA already has a lot of different kinds of images, and you can see like this is a 10.2 CUDA 10.2 QDNN7 runtime with Ubuntu 18.04. So this is what we are going to use, and or maybe not this one. Maybe we will use 10.1, because why not? So let's see if there is a 10.1 image here. Okay, not on this one. No. So probably I can just filter here. Okay, so we have some 10.1 images. So this is 10.1 QDNN7 Ubuntu 16.04 and 10.1 QDNN7 Ubuntu 18.04. So this is what we are going to use. So what you do is you have this inside Nvidia/CUDA, right? So you go to your Docker file and you modify this to this one and add Nvidia/CUDA. So now you grab the image from here, and it comes with all the runtimes that you need. Now the step is to build the Docker image. So it's we have already done it once, so we can just do docker build and provide the file name -t, which is the target. So this time I'm doing melanoma train and dot enter, and this is going to build the Docker image. So these steps take some time, and you see like Docker is also caching, it's using cache for different steps. So it's because I've already run it once, and now it's grabbing torch 1.5. So this step is going to take some more time, and it will install everything, and the image will be ready. So when the image is ready, we are ready to train. So as you can see, it has successfully tagged melanoma train. So now we are ready to train our models. So what we are going to do is we are going to docker run the train command, so which is also very simple, and we have already seen how to do that previously, right? But before we do that, let's try to run it first. Okay, so we do docker run, and then we specify what kind of image, target image. So that's melanoma train, and then you define the command, right? So that's not very difficult. So let's define one command called Nvidia SMI and see what happens. So you can see that even though I have GPUs on my machine, Docker is not able to detect it in its own container, and that's a problem, and that can be fixed by using the Nvidia Docker runtime. But So it's using that runtime. We already have that runtime. All you need to do is add another parameter, GPUs 1. Sorry, 2 hyphens and GPUs 1. So now you can see it's identifying one GPU on my machine and it's running inside Docker. And you can also change it to GPUs too. So I have 2 GPUs, so I can change it to 2 GPUs. So now it's identifying both GPUs inside Docker. And this is what makes our stuff quite simple. And what we can do now is we can just do Python 3 and main.py to train our model. So let's see if we can train our model. Okay, we cannot. So it's complaining about pandas. So that's one of the very important things that you must look at requirements.txt. So I will add pandas here. Never add without versions. I'm just doing it for the video. And then we need to build the container again. So it's again going to take some time. So let's build the container again. So whenever you change something in the code, you have to build the container again. Okay, so let's see how much time it takes now. It's probably going to take a lot of time because it has to download Torch again, and that takes time. So it seems like it is done now. So let's try training the model again. So using the docker run, same command, and see what happens now. So now it gives me this error that this file is not found. It's because Docker container cannot access your host machine, right? And that's the problem. And now what you do is you have to change a few things again. Before we go there, I would also like to explain you this Docker file very quickly. So we grab this image. So that's your from command. That's the first command most of the time. And then run command runs any commands, like so here you can run Ubuntu commands. So we are installing Python 3 and Python 3 pip. We are adding a user called Abhishek. We are changing the owner of the home folder of the user to Abhishek, and we are copying everything from here on the left hand side to a folder called app. We are changing the user to Abhishek now, and we are going inside the app folder and installing all the files from all the libraries from requirements.txt, and we are changing our working directory to the app folder. So now Docker, whenever you're running a Docker container, you can create as many files as you want or whatever you want, but it won't be saved as soon as Docker exits. As soon as your program ends, Docker is going to delete everything. So what do is we change the data path a little bit here. So instead of /home Abhishek workspace, which is my local address, I'm just going to use /home Abhishek data. Okay, and so this is my data path inside the Docker container now. So since we changed this, we need to build the Docker container again, and then again we need to wait for some time. So let's try building the Docker container again. Let me save this one. Okay, so now it's building the Docker container again. Let me see if I have something that I should explain you here. So all this is old stuff. You have already seen all of them in previous videos, so you must go through the previous videos once, and you must take care of the version of WTFML if you're planning to use it, because I changed it quite a lot. So we have everything. I think we do have everything. So now the concept of, so once we build this Docker container, we will run it again, but now with the concept of volumes. So what are volumes? Volumes are like locations on your host machine that you can map to the Docker container, and the Docker container can then modify it. So you can mount multiple volumes if you want, or you can just mount one volume. So it's just like creating a copy of a folder, and Docker container can modify that copy. And so when it exits, you will have everything inside the folder that you mounted. If Docker has changed it, then it will be changed. So we wait a little bit more for this container to finish. I think it's going quite okay, so should finish very, very fast now. Okay, so it's done. So now we can train our model again. So let's see what we had in the code. Did we have? So we still had 1000, so it's only going to train on 1000 samples. So now before training, in the command, what you can do here is you can use the parameter -b and then specify which folder goes where. So my home workspace melanoma data goes to home Abhishek data on the Docker container. Okay, so let's run it, and just so it's visible, let me show you again. So Docker run, then specify the number of GPUs, then -v parameter, which mount this folder from my local machine to this folder on the Docker container. And then you specify the target image, which is melanoma train, and then the command python3 main.py. Okay, and now we wait. So as you can see, it was able to read the data, but now it has to also grab this pre-trained model checkpoint, right? The ImageNet pre-trained model. So this step is going to take some time. I could have also put this in my local data folder, and instead of downloading the weights, I could have just loaded the state dict, but I'm not doing that. I'm just being a bit lazy here. So you can do that, and then you don't have to wait for training every time. So now we wait. So now it runs, and now we get another error, and it talks something about insufficient memory. So that can happen because Docker has to share the memory from the host machine. So to avoid that, what you can do is you can make the number of workers to 0 in your data loaders, but that's obviously not a good choice. So what you can do is you can use another parameter called IPC and set this to host. Now when you run it again, your model will work fine. So let's run it again and see what's happening. So you know that as I mentioned, Docker had already downloaded this file here. It had cached it, but now it's running it again because it doesn't save anything in when it exits. So now it's going to download the files again. So let's try one more time. So you can see now that the model is training fine and everything is going fine. It finished the first validation step. So now we will go. Now let me stop it first. Okay, so now we will go and see if the model file was saved. So in the code, I save the model in the same data path, which should be home Abhishek data. So we can go back to our terminal, and here I can just check if I have model 0.bin. So if I just do ls, so I'm getting model 0.bin. So I have the file. So this is how you can train using Docker, and we used PyTorch, but you can also use TensorFlow, obviously. And I hope you liked the video. I hope you enjoyed it. And if you have some suggestions, then let me know in the comment section. And if you like it, then click on the like button and do subscribe if you have not subscribed yet, and feel free to share it with your friends. And my book is also out, so if you like it, you can also buy the book. And whatever I explained today, some of it has been covered in the book also. So that's good. And thank you very much, and see you next time. Goodbye.